Today we'll be talking about how to calculate the volume of pyramids and cones. If you were doing well yesterday with the volume of cylinders and prisms, then you're going to do pretty well with this lesson as well. Basically, when we talk about the volume of a pyramid, it's going to be 1/3 the volume of the corresponding prism. If you look at this picture up here, you have this whole prism that I'm going to outline in blue. Now, if we had this same pyramid, and what I mean by same pyramid is the base is the same, and the height of the pyramid is the same, then the volume of that pyramid is going to be 1/3 of this prism. And there's a video here to kind of demonstrate that. So it is 1/3. So the volume of the pyramid is 1/3 times the area of the base. Remember, that's what our big B means. Area of base. Area of the base. And H is the height. So again, we got to figure out the area of the base and then multiply it by the height, and then multiply that by 1/3. Remember that multiplying by 1/3 is the same as dividing by 3. All right, so example 1 is asking us to find the volume of the regular pyramid. So when it says regular, that means the base is a square. So if this side's 14 here, that means this is 14 as well. So what we're going to do is we're going to first find the area of the base. So area of base. And since this is a square, we know that we can just multiply 14 and 14 to get the area. 14 times 14, which is 196. Then to calculate the volume, the volume of a pyramid is the area of the base times the height divided by 3. Well, we know that the area of the base is 196. The height, now it's important to know that the height is always perpendicular to the base. So the height goes from the top straight down and is perpendicular with the base and forms a right angle. So the height is 10, and we divide by 3. We put that in the calculator, and we get a volume of 653.33 cubic meters. Volume always has the units of cubic units, always. Now, you may remember from middle school, or the last time you talked about volume, well, isn't volume, length times width times height divided by 3? And yes, this works for a rectangular pyramid. Remember, all squares are rectangles. So yeah, you could have done 14 times 14 times 10 over 3, and you would have gotten the same answer. This formula here, where we multiply the area of the base times the height, that works for all prisms. This formula right here only works for rectangular prisms. So we can use this one for all prisms, triangular, hexagonal, and so on. Now, example number 2 is a bit different. The reason for that is because of this right here, this 13 centimeter length. This is not the height. This is what we call a slant length or slant height. And you can see that this does not go from the top straight down like the height should. So this pink line, this is what the height really should be. This is not the height right here. So we have to calculate the height. Well, what we can do is form a right triangle. And we're trying to figure out the height. We know that the hypotenuse is 13. Now this side right here, we don't know what that is, but since this whole length is 10, that means this part of it, or half of it, must be 5. So now we have a right triangle, and we can use Pythagorean Theorem. A squared plus b squared equals c squared. You could go ahead and do all the steps of the Pythagorean Theorem, or if you realize that this is a Pythagorean triple, you'll say, oh, x equals 12. Again, remember Pythagorean triples are nice whole numbers that work for the Pythagorean theorem, like the 3, 4, 5 triangle. This one is the 12, 5, 13 triangle. So now that we have our height, which is 12, we can then calculate the volume. So first we'll find the area of the base. The area of the base is going to be 10 times 10. Because again, this is a regular pyramid or a square pyramid. So we get 100. Then the volume is going to be the area of the base, which was 100, times the height, 12, divided by 3. We throw that in the calculator, and we get 400 cubic centimeters. Example number 2 is talking about the Pyramid of the Sun in Mexico. And it's a square-based pyramid, so that means it's just like the pyramids we dealt with above. We are given that the height is 63 meters and that the volume is 970,725 cubic meters. So we are given the volume and the height. We need to figure out the length of the base. So we're going to be doing what we did up here, but in reverse. Instead of trying to calculate the volume, we're going to be going backwards and trying to find, the side lengths up here. So let's set up the formula. So the volume is the area of the base times the height divided by 3. We know the volume is 970,725. And we know that is equal to the area of the base, which we don't know what it is, times the height divided by 3. So what we need to do is we need to get b by itself. Well, the first thing that I'm going to do is notice, hey, I can simplify that 63 over 3. So then we have 970,725 equals b times 21. Because 63 divided by 3 is 21. Then divide both sides by 21. And we will get 46,225 equals the area of the base. Well, we know what the area of the base is, but the problem is asking us for what is the length of one of the sides. Well, look in the problem up here. The area of the base was just 14 times 14, which was the side length. So what we need to do is figure out what number times itself will give us 46,225. What we can do is take the square root of this number, and that gives us the length of one of the sides. When we take the square root of 46,225, we get 212.66. So that is the length of one of its sides. So finding the volume of a pyramid is not all that difficult if you've already mastered the volume of prisms. All right, we're going to move on to finding the volume of a cone. Now, volume of a cone is going to look similar to the volume of a pyramid, and it's going to look similar to the volume of a cylinder. Just like with the volume of a pyramid, we can multiply the area of the base times the height and then multiply that by 1/3. However, in a cone, the base is always a circle. I think it would be far more useful to use this formula here. You could, though, still use the fact that B is the area of the base. H is the height. And R is the radius. If we look over here, again, here's both formulas. I will use this one instead. I just think it's a lot easier to deal with. You get everything done in one calculation instead of doing two separate ones like we did on the previous page. So if we look at this right here, find the volume of the cones. We'll start off with a pretty straightforward one. Volume equals pi r squared times h over 3. You may recognize that the top right here, well, that's the volume of a cylinder. And yes, that's true. The volume of a cylinder is related to the volume of a cone. You can just divide the volume of that cylinder by 3 to get your volume of the cone. We know the radius here is 10. We know the height is 16. Divide that by 3. We type that into the calculator. And when I type that in, I get 1,675.52 cubic meters. Now in example B, we don't have the height right here. So this is just like that one on the previous page where we had used Pythagorean Theorem to find the height. So if we look at this right triangle here, the hypotenuse is 9 and one of the legs is 4. This is not a Pythagorean triple, so we actually have to do Pythagorean Theorem. So 4 squared plus x squared equals 9 squared. And then we can solve this. 16 plus x squared equals 81. Subtract 16 from both sides. That gives us x squared equals 65. And then when we square root both of them, both sides, x equals 8.06. So that is our height. 8.06. Now we can use this in the formula for volume. So the volume of the cone is 1/3. Or again, you can divide it by 3. Let's do that because that's what I did on the previous one. So the volume is going to equal pi times r. The radius is 4 squared times the height. We calculated that to be 8.06. Divided all by 3. So when I type that into the calculator, I get 135.05 cubic feet. Now, your answer might be slightly different if you are using pi or 3.14, or maybe a little bit more decimals after 3.14 for pi. If you have the work all laid out and your answer is slightly different because you use a different number for pi, that's fine. All right, let's look at letter C. Now with letter C, we have the height is 25. We do not know what the radius is. We don't even know what the slant length is. What we do know is that this angle right here is 70 degrees. What that means is that we can use trigonometry to figure out what the radius is. So we know this is 70 degrees. We know the height is 25. We need to figure out what this side is. So then what we'll have to do is use Sohcahtoa. So if this is my angle right here, this is the opposite side. This is the hypotenuse because it's across the 90-degree angle. And x right here, this is the adjacent side. Opposite and adjacent is tangent. So what that means is the tangent of 70 degrees equals the opposite side, 25, over the adjacent, which is our radius. And then we have to solve this and get x by itself. So x times the tangent of 70 equals 25. Divide both sides by the tangent of 70 degrees. Now, trying to find this radius is more work than actually just finding the volume once we get it done. So x is equal to 9.1 centimeter. Type this into the calculator. That gives us our radius. Now we can calculate the volume. So the volume is pi times the radius, which is 9.1 squared, times the height, 25, all over 3. We type that into the calculator, and that gives us 2,168 cubic centimeters. All right, let's look at example number 4. The volume of the right cone is 1,350 pi cubic meters, and the radius is 18 meters. Find the height. So, just like that pyramid problem, we're given the volume and one other dimension. We now need to use that information to find the height of the cone. So volume equals pi r squared times the height over 3. We know that the volume is 1,350 pi. That equals pi r squared times h over 3. We know that the radius, let me replace the radius with 18. So let's simplify this a little bit. We have 1,350 pi equals pi times, 18 squared is 324 times h over 3. So what we'll do is we'll simplify 324 divided by 3. So this will give us 1,350 pi on the left side. We still haven't touched that, so we're just going to leave it alone. We have pi times 324 divided by 3 is 108 times the height. We can divide both sides now by pi times 108. We can write that as 108 pi because it doesn't matter what side you multiply from. So on the right side, the pi's cancel, the 108s cancel. On the left side, just the pi's cancel, and we are left to do 1,350 divided by 108. We type that into the calculator, and that gives us a final answer of 12.5 equals h. And that is our answer. All right, example number 5 uses Cavalieri's principle. Remember, all that tells us is that these oblique solids, or those oblique shapes, treat them as if they were right shapes. So it doesn't matter that this cone is not perfectly shaped as you would think as an ice cream cone. We still use the same formula. And with B, the same idea. Just because this is slanted does not mean you treat it any differently. So with letter A, what we'll do is the same thing. Volume equals pi r squared times h. Because this is a cone, we have to divide it by 3. So then the volume will equal pi times the radius, which is 1.1 squared, times the height, which is 2.7, all over 3. We type that into the calculator. The volume then is going to be 3.42 cubic centimeters. Now for letter B, this is a pyramid where the base is this triangle. So you can't just do 6 times 8 times 3 and get your answer. Because the base is a triangle, we need to find the area of this base first. Remember, the area of a triangle is 1/2 base times height. In this triangle, the base and height are 6 and 8 because they form a right angle. So the area of this triangle is going to be 24. Now that we know the area of the base, we can calculate the volume. And because it's a pyramid, you have to divide by 3. So the volume is going to be 24 times 3 over 3. You could type that in the calculator or realize, hey, a 3 on top and a 3 on bottom cancel, and we get 24 cubic feet. This is why I didn't want you guys to just always think, oh, volume of a prism is length times width times height. Again, this only works for a rectangular prism. This is not a rectangular prism. This is a triangular prism where the base is a triangle. So you had to find the area of this triangular base first, which is 24. Then the last example says you are making coffee using a cone-shaped filter. It takes 14 minutes to brew an amount of coffee that would be equal to the volume of the filter. So what that's saying is that the whole filter here is filled up with coffee, and it would take 14 minutes. Find the flow rate of the coffee in cubic inches per minute. So this could be a little bit of a tough question, but what we need to do first is find the volume of this. So what I want you guys to do is I want you to pause the video and find the volume of this filter, and then unpause it, and you'll see what we'll have to do from there. So go ahead, pause, and find the volume. Okay, so I got the volume to be 32.98 cubic inches. If you got something similar and just maybe round it differently, that's fine. Now to calculate the flow rate is going to be the volume divided by time. We know the volume is 32.98. We also know that it takes 14 minutes to brew coffee. That's a very slow coffee maker, by the way, if it takes 14 minutes. But this is also a large cone-shaped filter that we're using. So the rate, we type that into the calculator, is going to be 2.36 cubic inches per minute. I just typed that into the calculator. So that is our final answer. So I hope that this wasn't too bad. It was mostly taking what you may have already learned previously and kicking it up a notch, combining some stuff with it from before, like Pythagorean Theorem and trigonometry, areas of triangles. So we're kind of combining all that together to find the volume of these shapes. So hopefully you have a better grasp on this. So make sure you like the video and subscribe.